Dalton's law of partial pressure. This law was formulated by John Dalton, and this law states that the pressure exerted by a mixture of two or more non-reacting gases enclosed in a definite volume is equal to the sum of the partial pressures of the component gas in the mixture. Okay, so law states that the pressure exerted by the mixture of two or more non-reacting gases is equal to the sum of the partial pressures of the component gases. Okay. Also, the pressure exerted by the component gas in the mixture is a pressure exerted by the gas when it is present alone at the same temperature as that of the mixture. Okay. Also, the partial pressure exerted by the component gas in the mixture is same as the pressure exerted when it is present alone in a vessel. Okay, at the same temperature as that in the mixture. Okay. Now, let P total be the total partial pressure, total pressure exerted by the mixture, and P1, P2, P3 are the partial pressures, etc. are the partial pressures of the gases enclosed in a given vessel. Okay, then P total will be equal to P1 plus P2 plus P3 plus etc. That is, if P1, P2, P3 etc. are the partial pressures of component gases, and P total is the pressure exerted by the mixture. Okay, pressure of the mixture. Then P total will be equal to P1 plus P2 plus P3 plus etc. This is called as Dalton's law of partial pressure. Okay. We know according to Dalton's law of partial pressure, P total is equal to P1 plus P2 plus P3 etc. Okay. If we take two gases, P total is equal to P1 plus P2. And according to ideal gas equation, we know PV is equal to nRT. So P1 is equal to N1RT by V and P2 is equal to N2RT by V. So P total will be equal to N1RT by V plus N2RT by V, or we can write N1 plus N2 into RT by V. Okay. If we divide P1 by P total, this will be equal to P1 is N1 RT by V by N1 plus N2 RT by V. Okay, is equal to N1 by N1 plus N2. N is equal to N1 plus N2. So this is equal to N1 by N. Okay, and N1 by N is the mole fraction of the first gas. That is mole fraction is written as X1. For first gas, mole fraction is X1. So this will be equal to X1. So P1 is equal to X1 into P total. Similarly, we can write P2 is equal to X2 into P total, etc. Okay, etc. For ith gas, we can write Pi is equal to Xi P total. So, using this equation, Dalton's law, this is the general equation. Using this equation, we can find the partial pressure of different gases if we know its mole fraction and P total, that is pressure of the mixture of the gas, is known. Okay. Next, application of Dalton's law. An important application of Dalton's law is the calculation of the pressure of a gas. Calculation of the pressure of the gas collected over water. In the laboratory. Okay, so when a gas is collected over water, it is saturated with water vapor. Okay, so it exerts its own pressure and the pressure exerted by the water vapor. So observed pressure will be equal to pressure of dry gas, okay, plus pressure exerted by water vapor. Okay. And pressure exerted by water vapor is called as aqueous tension. Okay. So observed pressure or P total will be equal to pressure of dry gas plus aqueous tension. Okay. Aqueous tension. Also, aqueous tension increases with increase in temperature. Okay. So from this, P of gas will be equal to P total minus aqueous tension. Okay. Using this equation, we can find the pressure of a gas, okay, if we know the total pressure and aqueous tension. So this expression helps to find the this used for the calculation of the pressure of a gas collected over water in the lab. So this is an important application of Dalton's law. Also, aqueous tension increases as temperature increases. Okay. Next, a question based on Dalton's law. What will be the pressure exerted by a mixture of 3.2 gram methane and 4.4 gram carbon dioxide contained in a 9 dm cube flask at 27 degrees Celsius? Okay, and according to Dalton's law, we know P total will be equal to sum of the gases, that is partial pressure of methane and partial pressure of carbon dioxide. Partial pressure of methane is equal to N1 RT by V. Okay. So from this we can find N1. N1 is equal to given mass by molar mass. Given mass is 3.2 gram. And molar mass of CH4 is 16. It's equal to 0.2 mole. Okay. Now, substituting here 0.2. R is 0.083 into Temperature is 27 degree. So 273 plus 27 is equal to 300 Kelvin into 300 by volume is given 9 dm cube. Okay. So the answer is 0.553 bar. Okay. Similarly, P of carbon dioxide is N2RT by V and N2 is equal to 4.4 by 44 is the molar mass. It's 0.1 mole. Okay. So substituting here 0.1 into 0.083 into 300 by 9. Okay. Answer is 0.276 bar. And we know P total is equal to P of CH4 plus P of carbon dioxide. So P total will be equal to 0.553 plus 0.276. So sum will be 0.829 bar. Or we can write in Pascal, it will be 0.829 into 10 raised to 5 Pascal. Okay, this will be the answer. Second question, a mixture of hydrogen and oxygen at 1 bar pressure contains 20% by weight of hydrogen. Calculate the partial pressure of hydrogen. And we know partial pressure of hydrogen is equal to mole fraction of hydrogen into P total. Okay, P total is given, it's 1 bar. Okay, so first we have to find the mole fraction of H2. Mole fraction of H2 will be equal to number of moles of H2 by sum of the number of moles of H2 and O2. Okay, so number of moles of H2 will be equal to that, it is given, contains 20% by weight of hydrogen. That means if 100 gram mixture is present, it contains 20 gram hydrogen and the remaining is 80. So 80 gram oxygen is present. Okay, so number of moles of hydrogen will be 20 by molar mass of hydrogen is 2. So 10 moles. Okay, so next number of moles of oxygen is equal to molar mass will be equal to 80, the given mass by molar mass. Molar mass of oxygen is 32 and the answer is 2.5. Okay, so X of H2 is equal to number of moles of hydrogen 10 by sum of these two. Okay, 10 plus 2.5, that is equal to 10 by 12.5. Okay, answer is 0.8 is the mole fraction. Okay, so partial pressure of H2 is equal to mole fraction into partial pressure of total pressure of mixture, that is 1 bar. Okay, so answer is 0.8 bar. This will be the answer. Okay.